We have learned that like charges repel and unlike charges attract. These kind of forces are called the electrostatic force. But what is the magnitude of the force? Coulomb's law states that for 2-point charges 1 and 2, the size of force between them is given by this, where Q1 and Q2 are the amount of charges in units of Coulomb C. R is the separation between them in units meter. This symbol, pronounced as epsilon naught, is a constant called the permittivity of free space, and its value is about this. The forces on the two charges F12 and F21 form an action-reaction pair, which are equal in magnitude and opposite in direction. Now, compare Coulomb's law with Newton's law of gravitation that you have learned recently. You may feel that Coulomb's law looks more complicated. However, these two laws actually share the same structure. Both laws are describing the forces between two objects. Both forces are proportional to the relevant property of each object, that is, mass for gravitational force, charge for electrostatic force. Also, both forces are inversely proportional to the separation squared. Then how about the proportionality constant? For gravitational force, the constant is g. For electrostatic force, the constant is this combination, 1 over 4 pi epsilon naught. It is expressed in this way for some historical reason, but nonetheless it is just a given constant with the value of about this. The only essential difference between these two laws is the following. Gravitational force is always attractive, but electrostatic force can be attractive or repulsive depending on the sign of the charges. However, in VSE physics, we will only use the magnitudes of Q1 and Q2 in this equation to find the magnitude of the force, and the direction will be considered separately. Since Coulomb's law is so similar to Newton's law of gravitation, many skills for problems with gravitation are also useful here. For example, in this problem, we have 3-point charges P, Q, and R forming an equilateral triangle, and we need to find the force acting on R. Obviously, R is repelled by P and attracted by Q, so the force on R by P points away from P, while the force on R by Q points towards Q. Next, notice that P and Q have the same amount of charge, 15 nanocoulomb, and the same separation from R, 10 cm. Therefore, the two forces here have the same magnitude F, and by symmetry, the resultant force must point downward. To find its magnitude, we resolve the two forces into their horizontal and vertical components. By simple geometry, these two angles are both 60 degrees, so the horizontal component of each force is F sine 60 degrees, pointing in the opposite direction, and they cancel each other. The vertical component of each force is F cosine 60 degrees, both pointing downwards, so they add up to 2F cosine 60 degrees, which equals F. Lastly, we use Coulomb's law to find F, putting in the values, and the resultant force is this amount pointing downward. Done.